Hi everyone. I hope I'm audible to all. Okay, perfect. So guys, my name is Suneet and I've total 9.5 years of experience on big data systems. So guys, now we will get started with today's discussion. So basically, as a part of today's session, we will understand like what is data science, what is it all about, and what are the prerequisite or what are the things which you need to learn before you start your career on data science. Okay. So let me quickly get started with it. So this will be the agenda for today's session. So guys, we will understand like why data science, what is data science, who is a data scientist as in, what is the role of a data scientist and how a particular problem is solved in data science. Then we will be talking about data science components and then I will be showing you a small code. So yeah, everyone, let's get started. Okay, so let's talk about data sources. So guys, today we do have data flowing in from variety of sources. If I talk about the scenario which was there in the market 20 to 25 years back, it was entirely different. As in 20 to 25 years back, we all were not involved in generating this huge amount of data, right? But now, data is coming from various sources, plus we all are involved in generating this huge amount of data. So now if we talk about data sources, so what all types of data sources we have as in with the evolution of technology, data has started increasing. So it's like we can talk about, telephone, we can talk about desktop, we can talk about car, mobile, cloud, smart car. Everywhere data is getting generated. Okay, evolution of technology is one main factor for this for generating huge amount of data, right? Then we do have IoT. So IoT as an internet of things, so basically we can connect smart devices to all the items which we have in our houses. So now what will happen eventually, even those items will start generating the data, right? Then we do have social media platforms. So now when it comes to social media platforms, right, data is getting generated at a very, very high speed. So for them, right, data is huge and also it's getting generated at a very high speed. So if you talk about Insta, right, so per minute, these many pictures are getting uploaded, these many tweets for Twitter, these many emails for Gmail, and these many likes and photos are getting uploaded on Facebook, right? And when it comes to YouTube, every minute 300 hours of video is getting uploaded. So you can imagine the size of the data, and also you can imagine the speed at which data is getting generated, right? And when it comes to the other factors, so social media platforms, basically we say that, we are dealing with big data and most of the time participants will have this conception in their mind that only social media platforms are dealing with the huge data or big data, but that's not the truth. So in each and every domain, huge amount of data is getting generated. So you can talk about retail domain, insurance, transportation, government, education, healthcare, media and entertainment, banking and finance. So everywhere we do have huge amount of data. So it doesn't matter what your background is or from which domain you are coming, right? So you always have a scope to work on the big data projects. Okay. Okay, so now let's look at one use case. So basically, guys, so I'm not sure like if you have read it already or not, but this was published in the papers and all. So basically, data scientist and Walmart, right? They found a connection between Halloween and the sales of cookies, right? So that they said that okay, sales of cookies will increase when the Halloween is near, right? And there was one more use case where they found that the sales of strawberry pop tarts increased by 7 times before a hurricane. Okay, now Walmart, right? So Walmart, what it is doing, it is leveraging social media data to find out the trending products so that they can be introduced to Walmart stores across the market. Right? So these are a couple of use cases. So now if I go back to this and if I say that, how are they finding the relation between sales of cookies and the Halloween? Right? So this is something which a data scientist will be doing. So what is the role of a data scientist? As in, always you will have to find the relation, always you'll have to find the mapping or you'll have to find the connection. Okay, so now I can take n number of other examples as well, right? It's like how the movie industry works. It's like, producer will be spending the amount, and then so it's like producer will be spending the amount, and then producer is interested in getting the return. So producer will be selling it further. Let's say producer. So now the thing is, if someone is saying that I'm ready to spend this much amount on it, right? So he or she or the producer should be knowing, okay, this much return I will be getting. So how will that be happening? So it's like, again, machine learning algorithms would be running to find out, like, what will be the revenue out of it, or what I will be getting in return. So same thing when it comes to Walmart. So they have done a couple of analysis, and they are saying that we have found the connection between Halloween and sales of cookies. We have found it between strawberry pop tarts and the hurricane. And then they are saying that, okay, we know what are the products which are in demand, which we should start selling. Okay, so now all these are examples of data science. All these are examples of data science. So now let's understand what is data science. Okay, so guys, basically it's nothing but it's a data driven science. So it's like, based on the data, you'll be saying that, yes, I know how things are related with each other. Or what we say that it's a data driven science. It's an interdisciplinary field about scientific methods, processes, and systems to extract knowledge. The thing is, guys, you will be given the data, and the data will be of any kind. So it can be structured data, it can be unstructured data, or semi-structured data. The thing is, you need to apply scientific method, processes, and systems to get the meaning out of that data. That's what data scientists, that data science says. You will be given the data, and you will have to find the meaning out of it. Okay, so now when it comes to the data science, right? So basically, guys, data science is all about finding the relation. Okay, data science is all about finding the relation. So let me just take one very simple example here. Okay, so let's say that here what you have got is, you do have okay, I am just explaining. Let's say you have x1, x2, x3, x4, x5, and then you do have y. Okay, so guys, what are these x's? These are nothing but the independent variables. And what is this y? This y is nothing but dependent variable. Okay, so I can take one example here. Let's say that x1 is nothing but the CPU utilization, x2 is nothing but the number of VMs running, x3 is nothing but the time since how long it's running. Okay, and when it comes to the x4, we can basically, when it comes to the x4, we can also talk about, RAM. Okay, and other things. So now what is this y? This y is nothing but it will tell the probability, like if, like probability, like how many of these machines will fail. Okay, so this y will be giving the output as yes or no. Okay, so this is data science. So guys, what you need to do is, you need to find a function like this. Okay, so you need to understand the relation. Basically, you need to understand that how this dependent variable y is related with these independent variables. Okay, so always, so now if I can take another example, right? So let's say that here you do have got some financial data. Okay, and what is that financial data? This x1 is nothing but discount. Okay, x2 is nothing but price. Okay, and then x3 is nothing but how many products are getting sold. And what is this y is nothing like, order count. So basically we are saying that, okay, if this is a discount being given, and if this is the price, and if these many items are there in per packet, then yes, these many orders are getting sold. So always you will have to find the relation. So this is something which you will be doing as a data scientist, right? So that's why we say, now what is this CPU utilization, number of VMs, for how long it is running, and RAM? What are these? These are nothing but the data, right? So now this data will be given to a data scientist, and data scientist will have to find the meaningful information out of it, right? And how can that be done? That can be done by applying, scientific methods or tools. So that's what we are saying, that data science is all about finding the meaningful information out of the data. So basically, question that usually is asked to data scientists is, tell us something that we don't know, right? So as a data scientist, you'll have to find a relation. So in order to find that relation, or in order to find that equation, right, this is what you'll have to do. You need to have expertise in programming, statistics, and domain level knowledge. Okay. So now, who is a data scientist? Okay. So guys, in order to become a data scientist, you need to have expertise of all these. Okay. You need to have expertise with mathematics. Okay. Whatever we studied in our engineering, or whatever we studied in our, and whatever we studied in 11th and 12th standard, right? So you need to, revise those concepts, and yeah, you need to have expertise. Data science is methodology. So it's a way of getting the meaningful information out of the data, right? So when it comes to the mathematics, guys, you need to be good with statistics, discrete mathematics, information theory, decision theory, machine learning, right? And then you need to have the information system knowledge, like computer science, software engineering, system development. You need to have the domain level knowledge as well. Then you need to, you will be working as a statistical programmers as well. So guys, like I told you, right, that as a data scientist, your main objective is to find the relation of the data. So somewhere, right, so it's like somewhere the equation will be like m1x1 plus m2x2 plus c, right? Somewhere, let's say you will find one more equation, right? Then if the objective is to find the relation between these two lines, then you will come up with one more thing, right? You will say a1 y1 plus a2 y2, right? Somewhere when you deal with the x and the y, right, somewhere you will see a different kind of data. Let's say this is how your data is. When you plot it on the graph, right, it is coming like this. So now what will be the equation of this? Equation will become like this, right? So these are the things which you need to know. That's why I'm saying that in order to become a data scientist, you need to have expertise on mathematics. Okay. So yeah, this is what a data scientist is, having expertise on all these. But yeah, without the basic understanding of mathematics, I think it will be a bit difficult for you to survive. So now, role of a data scientist. So basically, data scientists will be responsible for designing and creating processes and layout for complex, large-scale data set. Again, this is a technical definition, but in layman's term, your role as a data scientist is to find that equation to get the meaningful information out of it by doing n number of things. Okay. And this is something which you will be doing for a large data set, right? And whatever research you will be doing, right, that might be for data mining and for research purposes. As an BBC is saying that I do have, n number of articles. So I need a data scientist who can build a model so that the model will tell me what is this article is saying about. Okay. So as a data scientist, you need to prepare a model. Once you feed that article to that model will say that this is what the article is all about, right? But when it says now let's say that there is this article published which is about let's say ragging, okay, and it is not having a single word like education, but we know that ragging and education are related, right? So in that case you will have to do a number of things. So at the end, this should not be the case that your model is saying that this article is not related to education because it is missing the keyword education. Okay. So these are the things which we handle in data mining and other research purposes. But I'm taking all these examples just to clear the picture so that you know that these are the things which you will have to do as a data scientist. So n number of things are involved. So what you will have to do, what will be the basic responsibilities? You'll have to select the features. Okay. So when we say features, so what are these? Like I was talking about X1, X2, right? I said that X1 is nothing but the CPU, X2 is nothing but the RAM, X3 is nothing but the number of VMs running, right? So now what is it? These are nothing but the features, right? Now let's say that someone has given you huge amount of data, and here, you see the name of the machine as well. Now you will say that, okay, name of the now you will say that, okay, on the basis of the name of the machine, I don't think so, like we can predict if this machine will fail or not. So you will say that, okay, this is a irrelevant feature, right? So you will say that, okay, all these features are relevant, but this is something which is irrelevant. So when the data will be given to you, what you will have to do is you'll have to extract the feature. You will have to extract the feature, and then you will be implementing the machine learning techniques. When I say that, you need to come up with the equation, or you need to come up with the relation such as y is equal to fx, that's nothing but machine learning algorithm. Okay, you have the data. On top of that data, you will be implementing this machine learning algorithm, and then you will be getting your final product or the model. Okay, so responsibility, selecting features and coming up with the optimized models, data mining, right? And then extending company's data. So somewhere you'll see that, okay, this data is not sufficient for the research purpose, and then you will be involved in the process where you will say that, okay, if we get integrated with the third parties, then we can get more data, right? So the purpose is more the data, more accuracy we will be getting. And also you will have to do the pre-processing, cleansing, and you will have to verify the integrity of the data for analysis purpose. And also you will have to build predictive models using machine learning algorithms. So role of a data scientist, or the end goal, is to come up with a predictive model using machine learning algorithms. Okay, so if I take example of financial domain or banking domain, right? So now let's say that someone is giving you this data. Okay, now let's say that someone is giving you this data, someone is saying like x1, x2, x3, x4, and what x1 says, if a person has car or not, if a person is already having house loan or not, if how many family members are there, what is person's let's say monthly income, take home salary, right? And then there can be other features or the attributes, right? And what is this y? This y is like, tell me if a person should be given the loan or not. Okay, so what is it? It's nothing but it's a predictive model. So you will have to come up with the model. So now when you will feed the new data to this model will say that, okay, now I know, I'll tell you for this if a person should be given the loan or not. And this is very general. Whenever you call for a personal loan or any kind of loan, right, they will be asking you all these questions, and then they will let you know your eligibility, and also they will let you know the amount, that okay, this much amount you can take, right? So all those things are happening, all those things are happening with the help of data science, or we say machine learning. Okay, so data science is everywhere these days. Okay, so how a problem is solved in data science. So that is something which we will discuss now, right? So as in, first of all, you will have to understand the user need. Okay, understanding the user need or user requirement is very much needed. Okay, so discovery, as in, you'll get the requirement, you will do some research or some analysis on that, and then you will say that, hey, this is the kind of data which I would need. Okay, or let's say that, the client or the user is coming and saying that this is the data which I have and this is my requirement, so tell me what else do you need, right? So what you'll have to do is you will have to understand the user requirement first, and then you will start working on the data preparation. Okay, you will be preparing the data so that so that the machine learning algorithms can be implemented. Discovery, data preparation, then you will be coming up with a model. You'll say that, okay, this is a machine learning algorithm I should be applying for building a model. So once the model is built, you will be deploying it to the prod, and then you will be communicating the results. So now let's discuss all these phases in detail. But as a data scientist, right? So you will always be working on these phases. Okay. So now what is the first phase? First phase is discovery. And what it says, so basically it involves acquiring data from all the identified internal and external sources, right? So once you have understood the problem, you'll say that, okay, I would need this kind of data. And then you'll be saying, okay, the data can be collected from these internal and external sources. And this data, it can come from logs, it can come from social media data, it can be a census data set, or it can be data stream from online sources via APIs, right? Data stream from online sources via APIs. So now after the discovery, right, you have got this kind of data. Okay, you did the discovery and you have collected the data from internal and external sources, and this is how a data looks like. So here what do you have? You do have attributes, or you do have the features. So now what is this data? This is nothing but this is the medical data, or this is the history of a patient, like glucose, BP, right? Top scan, BMI, age, income, right? So now this is the data which you have received. So one thing is, because it is the patient's history, right? So by looking at income, you'll say that this feature is irrelevant, right? So again, this is your job as a data scientist, to get rid of the irrelevant feature, or to get rid of the irrelevant attributes. Okay. So now when it comes to the data preparation, right? So guys, in this data, right? So you will get a lot of inconsistency, like somewhere you will get missing values, somewhere you will get blank columns, abrupt values, and incorrect data which has to be cleaned. So now let's say that you have this data, and in this data you see that for a person, right, it is showing BP as 0. So for a living human being, it's not possible, right, to have BP as 0, right? So by looking at that number, you will say that, hey, this is something which is junk value. Or now let's say that for a person, age is missing. Okay, no age is provided. Then again, you'll say that, hey, I need to I need to clean this data. So that's why and somewhere, right, because these are the manual entries which are being made, and someone might have entered some abrupt value. Now let's say that um, for BP only, it is entering the value as 9999, right? So you'll say that, no, this is very abrupt, this is not possible, right? So 70% of the work is done in the data preparation. Okay, so you will have to get rid of the inconsistency, as in missing values, blank columns, abrupt values, and incorrect data. So it's not that whatever data you have received, you'll start doing the analysis on that, or you'll feed that data to the model. You will have to do the pre-processing, right? It is required to explore pre-process and condition data prior to modeling. This will help you to spot the outliers and establish a relationship between the variables. So now this is one case, okay, outliers. So what it says that, in the data preparation, you will get rid of the outliers as well. So now let's say that someone is asking you to, you know find the average salary of all the developers in the organization. Okay, so now this is the task. Okay, so now what you have been given, the salary range of all, or salaries of all the developers, plus you do have the salary of CEO as well. Okay, so tell me, do you think that for calculating the average salary of all the developers, we should be considering the average salary of CEO as well? No, right? Perfect. So what is it? This is nothing but it's a outlier. Okay. What is it? It's nothing but it's a outlier. So we are saying that this is something which we should not be considering, because if we consider this, our results will change abruptly. Okay. What we are saying that this is something which should not be considering. If we consider this, our results will change abruptly. Okay, so now when it comes to the question of finding an outlier, right? So basically, there are n number of things. So now this question was being asked, like, why this mathematics is needed, right? So now when you are dealing with huge amount of data, it's not that, manually you will be checking, you will be plotting the graph and you will have to visualize the graphs, and for calculating the outliers, right? Basically there are formulas given. Let's say for outlier, right, you will have quartile. So as in, let's say these are the number where you will say 3, 3, 6, 7, 7, 10, 10, 11, 13, 10. So what you will do is you will split it to the four quartiles, right? And then basically it is Q1, it is Q2, it is Q3, it is Q4, right? And then I'm just giving you the example, guys. You don't need to go into the detail. Then what do we have? We do have an interquartile range, which says like it is nothing but Q1 minus Q3, and then we do have a step. So basically formula for that is 1.5 into interquartile range, right? And then basically we will be applying n number of formulas to finally to know like what is the outlier. So now if you see here, what is it? This is nothing but the mathematics involved, right? So now again, if you say like why are we doing this Q1 minus Q3, right? Again, for this you need to have understanding of mathematics. Or if you say like why are we multiplying it with 1.5, right? Who is giving this number? Again, these are the optimized value. But I'm just saying that because you will be dealing with huge amount of data, you cannot do all these things manually. That's why you need to have the understanding of mathematics, because for everything you will find n number of formulas. Okay, and those are the formulas which you'll have to apply. Or let's say when it comes to the pre-processing, right, we do have the concept of scaling. Scaling as in, let's say that you are interested in plotting a graph of x with respect to y, right? But you see that for one, right, range is very high, right? Let's say for y-axis your range is like this much. So now if you plot the graph for this range, right, it will go very high and it will become a bit difficult for you to analyze the graph, right? So it'll become difficult for you to analyze the graph. So in that case, what you'll be doing the scaling so that it can fit into a readable range. Again, for that, right, so we do have a different formulas. Okay, or for standardization we say like x minus minimum over maximum minus minimum. Okay, so these are the things which you need to know. So yeah, as a data scientist, right, you will get rid of the inconsistency. You will have to find the outliers, and most importantly, you will have to establish a relationship between the variable. Y is equal to fx is something which is your job, right? So now if you look at this data, right, you see for BP, you see the abrupt value, and then you see one, which is basically, a kind of junk value. It should have been int, and you see some missing values. And also you see that income is irrelevant. So now what you have done is you have filled the values. So now you must be wondering how have we changed the abrupt value of BP with this 80, right? So again, there are formulas. So it's like sometimes you will fill this value with the mean of all the columns or the median, right? So those are the things you will get to know once you start working on it. But basically there are formulas which you will have to apply. Okay. So once you are done with the data preparation, you will go ahead with the model planning. So now what you'll have to do is you'll have to create the model. So what are the common tools for model planning? Basically, we have SQL analysis service, right? Then R can be used, then SAS or any other tool can be used, right? And also, when it comes to the model planning, you need to know the visualization techniques, or like how to visualize this histograms, line graphs, box plot, or you'll have to get a fair idea of the distribution of data, and that's why statistical understanding is needed. Okay, So model building. So once the model is built, right, what you'll have to do is you will be once the model is built, right, you will be putting it to prod. It's a model as in, so here what you see a decision tree. Okay, it is giving you a different path. It is saying that if a person is glucose is this, and if a person is pregnant, and if the age is this, and BMI is this, then report is negative. Now let's so once it is done, you will have to deploy it. So basically, when it comes to the deployment, you will be deploying this model as a web service. Again, the deployment part is not being covered here, but there are different ways of deploying a model. So if you are using Azure, it has got its own ways, like you can create a Docker image or things like that. When it comes to AWS, there are different ways, but now let's say that you are not interested in using any of the cloud provider, and now how do you deploy that, right? So but the other thing is you'll be deploying it as a web service, so that when the new data is being fed, right, you will be getting the correct output, and then you will be communicating the results, and also will get to know like how, and you'll have to find the accuracy of the model as well. Again, for finding the accuracy, there are formula like true negative plus true positive divided by total number of outcomes. Okay. So yeah, now you are getting a diabetic positive set and the negative set, right? Okay, yeah. So this was the question, right? So how to choose algorithms in data science. So this is the answer. So basically, when it comes to the algorithms in data science, we do have all these types of algorithm. We do have classification algorithm, anomaly detection, regression, clustering, reinforcement. So if user is saying, tell me if this is A or B, you will be going with classification. If user is saying, tell me, is this weird? Then you will be going with anomaly detection. Or if user is saying like how many products should get produced or manufactured, or how much, how much should be the quantity, then you'll be going with the regression. So basically regression algorithms will give you the range of the numbers, right? So as in, if I say how much loan should be given to this person, so what is that would fall under the category of regression. Okay, how is this organized? Basically that's a clustering algorithm, as in when someone says that, okay, I do have these users, these are the preferences of different users, create group out of it. Okay, then this is nothing but clustering. And what should I do next? That's nothing but reinforcement. So here it's like machines will start learning on its own. Okay, but when it comes to the data science, right, it's about classification, anomaly detection, regression, clustering, and reinforcement. Okay, so now as a data scientist, you need to know all these algorithms in detail, like how are these algos working, what is the best way, and everything. So now types of machine learning algorithm, basically guys, now I'll just give you the introduction, like what are the types. So here what we have is we do have supervised learning, reinforcement learning, and unsupervised learning. Supervised learning, guys, it's very easy. So basically someone is telling you, or there is a teacher who is teaching you. So guys, we talked about X and Y, right? Okay. So I'm saying CPU, RAM, number of VMs running, okay, time running, and I'm saying when CPU utilization was 90%, RAM was 2, number of VM running was 1, time running was 4 hours. What happened in the past? Machine went down, machine crashed. Okay, let's say this. Fine. So now in this case, you do have the value of Y already. You have the historical data. Basically, you are saying that I know last time when these were the values, this was the output. Fine. So what is this? This is nothing but the example of supervised learning. Someone is telling you, there's a teacher who is telling you that, hey, based on my experience, I'm telling you that this is how it happens. Now you need to learn from this. That's the example of supervised learning. When it comes to unsupervised learning, as in no one is telling you. So now the value of Y, right? It's not there. This is not there, right? It is unsupervised. So you don't have the historical data. But when we talk about unsupervised learning, as in someone will give you the data set. Let's say that you do have, articles. Let's say you do have article A, B, C, D, okay? And then you do have user 1, user 2, okay? You are saying user 1 has read article A and D, user 2 has read article B and C, and then there is user 3 who is article D. So now what a user or what requirement you are getting? Basically, user is saying that create groups based on user preferences. Create groups based on user preferences. So what you don't have here, so basically you don't have Y here, right? That's why we are saying that this is nothing but this is the unsupervised learning. So there is no one who will tell you that, this has happened in the past. So when kids are taking decision out of their own understanding, this type of learning would be unsupervised learning. Supervised, you know the value of Y. So you know this was the output of Y last time. Unsupervised, it's like the requirement is different. You need to create groups out of it, right? Okay, it's totally clear, right? So that's why it is unsupervised learning. Now, when it comes to reinforcement, right? It's like if a new situation comes up, right? So what kids will do? Kids will take actions on their own based on past experience, right? But as a parents, towards the end of an action, you can tell him whether he did good or not, right? It's like now you're saying you're telling this thing to a machine, you do whatever you feel is right, then later on I'll tell you if it was good or not. This is nothing but the reinforcement learning, right? So now this field, right? So when it comes to the reinforcement learning, it's like basically it's a bit complex. It's like in reinforcement learning, machines will have the power to learn things on its own, right? And it is inspired by behaviorist psychology, concerned with how software agents taught to take actions in a new environment. So now let's look at the exam. Okay, so now when it comes to reinforcement learning, right? Self-automated cars. So what are those? Those are nothing but the example of reinforcement learning, right? So now K means clustering. So guys, this K means clustering algorithm, right? This is the example of unsupervised learning, okay? So here what you need to do is you need to create groups out of the data which is given. Okay, what you need to do is you need to create the group out of the data. So now when it comes to K means clustering, so let's just look at it. Guys, and it is the most, widely used clustering algorithm. So clustering, as in I took the example, right? Where I said that, yeah, what you need to do is basically what you need to do is you need to create groups out of the data, as in you need to create the groups based on the user preferences. Okay. So now what you have is you have the data here. Okay. So guys, can you tell me by looking at the picture that how many groups are there? So guys, basically, right, there is no clear representation. So now let me just draw it here. Okay, I do have this and I do have data here and I do have data here. So how many groups you see, guys? Clearly you see two. Now if I do this, how many clusters or groups you see? Only one, right? But what is K means clustering? It says that you need to create clear clusters like this, like this. Okay, so it says that you need to tell that, okay, this is the group which, or this is the cluster which belongs to the age group. We can say less than 60, or we can say that this is the group where the preference was mostly for branded shoes. Or we can say that this is the group where preference was for clothes, things like that. Okay. So now K means clustering is used to create cluster or group like these. Okay, so how this algorithms work? So basically I'll give you the basic idea, like how is it working. So first of all, randomly you will be initializing K points called the cluster centroids. Okay, so you will say that, okay, we are interested in calculating two clusters. I'm saying k is equal to 2. Now I'm pretty sure that all of you must be having this idea in your mind that how are we coming up with this, where we are saying that k is equal to 2. Guys, again, it requires a deep nth level discussion of mathematical formula and this algorithm in detail, where we'll say that, okay, what you can do is you can try changing the numbers, right? Once the clusters get created, then there is a way to check like if the clusters are far away or not. So basically the objective is to create clusters which are far away. In that case, we will be saying that yes, this is the optimized number, and out of this data set, these many maximum number of clusters or the groups can be created, right? So first, what you will be doing, you will be initializing k points at the cluster centroid. Okay. So now in here, let me quickly just do this. Okay. I am saying that for this is the center, and I'm saying this is the center. What you need to do is you need to initialize two random points. Okay, then what it will be doing is it basically you will be initializing the cluster centroids. So we are saying there are two centers, right? And now value of k or number of clusters can be determined by the elbow curve. Okay, so again this elbow curve is something which requires, like, this is something which we studied in our engineering, right? So basically what is this elbow curve? I'll just draw it here and then I'll tell you. It says this, right? So it says the number which will be here, right? So this is nothing which will give the best result. So it says that k is equal to 1, right? As in the error will be higher, but once it's like if we start, so basically what it says that for k is equal to 1, right? So as in it clearly indicates that you will get the best values when you are under this range. As in k is equal to 1, error is higher, and then it starts reducing, right? So that's why we are saying that okay, this is the thing, and it is nothing but it's the elbow curve. And if you are really interested in understanding this in detail, I think we need at least 1 to 1.5 hours just to discuss this, like how are we saying that at k is equal to 1, error is higher, and the elbow curve will give the best value of k. So basically, it's nothing but sum of squared errors. Okay. So yeah, for sum of squared error, you will be getting this kind of graph. Okay. So yeah, now centroid, right? And value of k, it will be determined by the elbow curve. Then what will happen? Next slide. So it's like next point is now here you see two centroid. One is here and one is here. Okay. Again, you see, you will have to now next point is you will have to calculate the distance of each point from this centroid. Okay. So what this algorithm says that you need to calculate the distance of the data point from the centroid. And how will you be calculating the distance? This is the formula which you will be using. So again, in order to understand this, you need to know mathematics, right? So the point is, depending upon the minimum distance, data points are divided into two groups. What it will be doing, it will keep on basically calculating the distance. So it will say that, okay, what is the distance of this with this, right? So at the minute, what it will do is the points which are closer to the centroid, right? It will be creating one cluster of those, and then it will be creating one more cluster. And then again, the centroid will get calculated, and this thing will keep on happening every time. Now what will happen, it's like now once it has created the cluster with the points which are nearer to it, what will happen, the centroid will get moved. Okay, so now the centroid has moved. So now if you do like n number of iterations, right, you will get to know now the centroid, now the two clusters are really far away. So now what you see is you see that all these points are nearer to this centroid and all these are nearer to this, right? And for how long you'll continue running this iteration until the centroids stop changing. Now you will say that okay, centroids are not moving, and we have got the optimized number of clusters. Okay, So this is something which you'll say, or basically, or what you can do is for checking the accuracy, or if you want to say that you have got the best clusters or not, what you will be doing. Let's say that this is cluster 1, this is cluster 2. So there are formulas. So basically for this you will calculate the radius, and for this you will calculate the radius. So basically if d12, right, or if for 1 point, right, it is greater than the other two radiuses, right? So let's say that I am saying that the diameter, or basically you will have to calculate the radius to check if it has exhausted the k or not. Okay, so here you see R1, here you see R2. So if you see that the clusters are really, really far away, then you'll say that you have come up with the optimized number. So this algorithm, it's pretty easy to understand. First of all, two random centroids. Then you will run the algorithm. What that algorithm will do, it will calculate the distance of each point, and how that distance will get calculated. That distance will get calculated based on this formula, right? And then it will be moving the point, it will be calculating the centroid again, and it will continue doing this n number of times till two clear clusters are created. And how can we check, like, if we have got the optimized clusters or not? So basically we do have formulas on the basis of which we will be calculating the accuracy, right? So now here you do have two clearly created clusters, right? So this is cluster 1 and this is cluster 2. Okay, everyone, then let's wrap up the session. Thanks for joining.